The Eiffel Tower, engineering against all odds. When construction began in 1887, the engineers of the Eiffel Tower faced challenges far more complex than mere height. The iconic structure, now synonymous with Paris, was initially loathed as an eyesore, with a contract that mandated its demolition after 20 years. Yet today, this 7,300-ton iron marvel not only stands but endures as a testament to 19th century innovation. The real story lies in how its builders overcame impossible odds, from unstable riverbed foundations to the puzzle of constructing the world's first curved elevator. Foundations on shifting ground. The towers, for elegantly slanted legs, each set at a 55-degree angle, presented an immediate dilemma: how to anchor them securely when two stood on dry land and two on the soggy bank of the Seine River. This asymmetry threatened the entire predicating tilt in the foundation would doom the structure. On the dry side, engineers excavated down 7 meters to a firm layer of sand and gravel. There, they built rectangular pits filled with hydraulic concrete, a blend of lime, clay, and gravel that hardens even underwater. Above this, limestone pyramids were constructed, angled at 54 degrees and embedded with long iron anchor bolts. The riverside was far trickier. Digging simply filled with water. This solution, pneumatic caissons, massive bottomless wooden chambers forced into the earth. Compressed air was pumped inside to keep water out, allowing workers to excavate in the dry. As soil was removed, the caissons sank nearly 30 meters until they reached solid ground, once filled with concrete and topped with matching stone pyramids. These foundations were locked in place by a clever, arched retaining wall. The arches diverted lateral pressure from wet soil, preventing cracks, a technique later echoed in the Taj Mahal's Yamuna Riverbank Foundation. 1,000,000 rivets and pure iron, the tower rose as a giant jigsaw puzzle. Over 18,000 prefabricated parts were hauled to the site and assembled using more than 2.5 million rivets. Teams of workers heated rivets until glowing, inserted them into holes, and hammered them tight. As each cooled, it contracted, pulling the iron plates into an ironclad grip. The material itself was key. Puddled iron, 99% pure with minimal carbon. This composition, combined with natural slag fibers, made it exceptionally rust-resistant. Major reason the tower still stands with minimal corrosion over a century later. The millimeter precision alignment. Perhaps the most nail-biting moment came when the 4 independent legs, each 1,500 tons, reached 57 meters and needed to connect to the first platform. Tiny variations in their positions could have been disastrous. Engineers had anticipated this. The anchor bolts at the base were set within gaps, allowing for micro-adjustment. Using hydraulic jacks and temporary wooden supports, workers nudged each leg with micrometer precision until all 4 aligned perfectly. Only then was the first platform bolted into place, stabilizing the entire base. Conquering the curve! The elevator dilemma building the tower was one challenge. Moving people up, it was another. Straight elevators wouldn't work inside the sloping legs. The American firm Otis, initially hesitant, engineered a revolutionary solution: a hydraulic curved elevator. Inside each inclined leg, a cab ran on rails, pulled not by a direct cable but by an endless chain, looped over pulleys. Power came from a horizontal hydraulic ram housed underground. As the ram extended 1 meter, it moved the pulley system, lifting the cab 8 meters. The system was so efficient and smooth that it remained in use for decades. For the final vertical climb from the 2nd floor to the summit, engineer Leon Edu installed a dual lift with 2 counterbalanced cabins, each acting as the other's counterweight. From scorned to celebrated. Completed in 1889 as the tallest structure in the world. The Eiffel Tower was saved from demolition by the dawn of radio technology. Its height made it a perfect antenna. Now, at 330 meters, with modern additions, it draws millions annually. More than a landmark, the tower is a lesson in resilience and ingenuity. It tackled unequal foundations, perfected and invented inclined elevators, all while weathering public disdain. Every rivet, arch, and hydraulic ram tells a story of problems met with relentless creativity. In defying both gravity and critics, the Eiffel Tower didn't just rise above Paris. It elevated the very possibilities of engineering.